Hi, my name is dr. Ahmath. In this video lecture, we are going to start discussing about the least squares approximation. So this is going to be the series of two video lectures where we are going to solve this problem using calculus tools, so essentially by minimizing the functionals. And in our next video lecture, we are going to discuss about how we can solve this least square problem using the linear algebra tools. So let's start from discussing what is basically the problem. So let's say you are given 2 points on the coordinate system, on the rectangular coordinate system, and you would like to figure out the equation of a line which is passing through these 2 points. So the equation of any line is going to be in the form of kx plus c, for example, where k and c are going to be the constants. And what you have to do is you need to figure out what is the k and what is the c. So if you're given 2 points, you can easily find, for example, the slope of the line. So the slope of the line is going to be, I'm going to write this here. So the slope of the line is going to be the difference of the y coordinates of this point. It's going to be 0 minus 3 divided to the difference of the x coordinates of these 2 points. It's going to be 5 minus 0. It's going to be minus 3 over 5. Then we can find the c from this equation, right? So the c is going to be equal to the y minus kx. Okay, so we know all of these ingredients. So you can just substitute one of the points to here into this formula and figure out what is the c. So the c is going to be equal to y coordinate of this point is equal to the 0 minus k. We've just found that the k is equal to the minus 3 over 5 times to the x. It's the x coordinate of this point here, which is 5. So it's going to be equal to the 3. I mean, actually, it is clear that the b is equal to the 3 because it is intersecting the y-axis at this point, at the 3. So the equation of the line is going to be minus 3 over 5 times the x plus 3. Well, this is how we can figure out the equation of a line which is passing through the 2 points. But the problem arises in practice, most of the time, we're given lots of points and we would like to try to understand the trends of this point. So, or essentially the correlation between x and y, for example. And in this sense, it would be really important for us to create a line which is passing through all of these points. But obviously, it is not possible to do this, right? And what we are going to do is we would like to figure out the line which is going to fit to these points in the best way. Okay, and what does it mean that this is going to fit in the best way? So we are going to play with the parameters of this line. So the any line is going to be written as the kx plus c, right? Where the k actually means the slope of this line. So actually we can rotate this line, right, to a little bit. So this is how we can control with the values of the k. So if you change the values of the k, you can just rotate this line. And the c, what is basically c is controlling the height of this line. So we can just put this line up and down. Okay, so there are two parameters of this line, so of any line, k and c. So they are going to control the slope and the height, the y-intercept. Okay, and by just controlling this, so what we have to do is we need to figure out the best values for the k and c. Okay, and this is how we are going to do this. And what we say by claiming that this line is going to be the best is basically so that the average distance or the total distance from this line to all of the other points should be minimum. Okay, and this is how we are going to define the distances. So let's say I'm going to choose this point here, so that this point is going to be along the same vertical line. So that's why it's going to have the same x coordinates. Okay, so that's why the coordinates of this point is going to be equal to the simply 0 and y1, where 0 is the same as this one. Okay, so I'm going to choose the second point here along the same vertical line as the second point, as this point. Okay, so that's why the x coordinate of this point is also going to be 1 as the x coordinate of this point. Okay, so any point along a vertical line is going to have the same x-axis, x coordinates, right? And I'm going to choose the third point here, so which is going to have the x coordinate the same as the third point. So the x coordinate of this point is going to be the same as the x coordinate of this point, right? So the only problem is what are the y coordinates, okay? So fortunately, we know the equation of this line, right? And if you know the x coordinate, you can find the y coordinate by just substituting the x coordinate to here into this equation, right? So, well, if you are going to substitute, for example, the x coordinate of this point, which is equal to the 0, to this equation, what you get? It's going to be y is equal to the k times the 0 plus b, right? Which is going to be simply equal to the b, right? At the same time, if you substitute the x coordinate of this point here into this equation, what you get is, so y is going to be equal to the k times the 1 plus c, right? And if you substitute the x coordinate of this point into the equation, it's going to be y is equal to the k times the 5 plus c. Okay, so now we know all of the x and y coordinates of these points along this line. Okay, so it's going to be simply c for the first line. So it's going to be simply c here. It's going to be k times the 1 plus c for the second one, and it's going to be 5k plus c for the third one. And we obtained the y coordinates of those points by just substituting the x coordinates into the equation of the line. Okay, so now what we have to do is we need to figure out the distances, right? So, well, the distances between the 2 points in the rectangular coordinates have been found by just taking the difference of the x coordinates and the y coordinates and squaring them and summing them, right? For example, if you're given this 2 points, so let's look to these 2 points. So the distance between them in the square is going to be equal to 0 minus 0, the difference of the x coordinates in the square, plus 3 minus c in the square, the difference of the y coordinates in the square, okay? So the distance for here, for the second one, it's going to be equal to the, so 1 and 1, I'm not going to take the differences of the x coordinates because it is already clear that it's going to be equal to the 0 because they are lying along the same vertical line, right? So here it's going to be equal to the k plus c minus 2 in the square. And the third distance here is going to be equal to simply 5k plus c, right? So minus 0 in the square. Okay, so I found all of these distances, and the distances have been found by just finding the simple distance between the 2 points in the rectangular coordinates. Okay, so for the first one, it's going to be the difference of the y coordinates. This is 3 minus c. For the second one, it's going to be like this. And for the third distance, it's going to be like this. Okay, so what I want is, so you see, so all of these distances are going to depend on the 2 parameters again. So on the k and on the c. So what we need to do is we need to figure out the best values for the k and c. And what we say by the best values is that the total distance, basically the sum of all of the 3 distances, should be minimum. Okay, so that's why I'm going to create so-called functional, which is going to depend on the 2 variables on the k and c. Okay, so let's simplify this a little bit. So it's going to be look in this way. So which is going to depend on the k and c. So what we need to do, so that this functional d is simply the total distances. So what we have to do is we need to find its minimum value, least squares value, right? So you see, so there are lots of squares there, and we have to find its least value, okay? So in order to do this in calculus, what we need to take the partial derivatives of this functional with respect to the k and with respect to the c and equalize them to the 0. Okay, so essentially we have to take the partial derivative of this functional with respect to the k, and the same functional we have to take the partial derivative with respect to the c and equalize this to the 0. So let's try to do this together. So for the first one, so you see, so we need to use like a so-called chain rule, so or just a power function. So the derivative of the x squared is going to be simply equal to the 2x. Okay, oh, you don't see this there. So the derivative of the x squared is going to be equal simply to the 2x. Okay, so I'm just going to use this formula. So let's substitute this for the first one. It's going to be 2 times to the k plus c plus 2 plus, so there is no k in the second one, right? So that's why the derivative is equal to the 0. And the derivative of the third one here is going to be equal to the 2 times, oops, so there should be k, sorry. And this should be c. Okay, so sorry for the typo. So it's going to be 2 times to the 5k plus c times the derivative of the 5k, which is equal to the 5. okay? And we have to equalize this to the 0. Now we need to take the derivative with respect to the c from the second functional, right? So here, I can take this derivative. It's going to be 2 times the k plus c plus 2 plus. So here we can still take the derivative because there is c. It's going to be 2 times to the c minus 3. And here we can still take the derivative. It's going to be equal to the 2 times to the 5k plus c. And this is also equal to the 0, okay? So what we need to do is we need to simplify this. So we derive the system of linear equations, which has 2 variables, k and c, and 2 equations, and we can like easily solve this problem. So what I'm going to do is I'm going to just eliminate these 2's and write down the equation. It's going to be k plus 25k, which is going to be equal to the 26k. Plus, so we've got c here and 5c here. It's going to be 6c is equal to the minus 2, right? So this 2 here is going to go to the right-hand side part. It's going to be simply minus 2. Okay. At the same time, so let's simplify the second equation. So here we have 2k and 10k. It's going to be equal to the 12k. Okay. So we have 2c, 2c, 2c. Right? So it's going to be equal to the plus 6c. And this should be equal to the 4 minus 6, which is going to be equal to the minus 2. If it goes to the right-hand side part, it's going to be equal to the 2. Okay? So we take the partial derivatives of the functional with respect to the first variable and the second variable. We equalize this to the 0, and we obtain the system of linear equations. And this is what we are going to solve now. So in order to solve this, so you see, so there are 6c on the first equation and 6c on the second equation. We can just subtract them in order to get rid of the 6c. It's going to be 14k is equal to the minus 4. So that's why it is clear that the k is equal to the minus 4 over 14. Or k should be equal to the minus 2 over 7. Okay? So we are going to substitute this either to the first equation, either to the second equation in order to find the value of the b. So for example, let's sorry. So let's find this 6c from here. So 6c is equal to the 2 minus 12k, right? So which is equal to the 2 minus 12 times the z minus 2 over 7, okay? So I'm going to open the brackets and I'm going to simplify the term. So by giving the common denominator, it's going to be 14 minus 24, or plus 24 in this case, right? Okay, so divided to the 7. So this is what is 6c, so that's why the c is going to be equal to the 38 divided to the 42, or simply 19 over 21. Okay, so if you write this down, the value of the k and c in terms of the decimal numbers, it's going to be equal to the minus 0.28 roughly, and this is going to be 0.9. And so numbers. Okay, so this is the 2 values of the k and c, which would minimize that functional, and they are going to draw this line. Okay, so our line, which is going to fit to our data, to this 3 points, is going to be so k, which was equal to the minus 2 over 7, right? Plus kx plus c, which was equal to the 19 over 21. Okay, so this is how we are going to solve the problem, the least square problem, using calculus tools, or basically by minimizing the functionals. So in our next video lecture, we are going to discuss how we can solve the same problem using the tools of linear algebra, essentially by using so-called orthogonal projections. So thank you very much. I hope that this was helpful.